We take the sources, unpack them, and really pull out the essential knowledge for you. Today, we are turning the focus entirely inward. We're doing a deep dive into, well, us, the hidden reality of the human body. And we're starting with something you might have heard, actually. This old bit of trivia kicking around since maybe the 60s. The idea that, chemically speaking, your body isn't worth much. They used to say you could buy the raw ingredients for, what, $5? Something like that. It's supposed to make us feel humble, I guess, just common stuff.
Yeah, it's a nice thought, very poetic, but it really undersells things quite a bit. When scientists actually did the math, looking at the purity needed and everything, well, based on prices around 2013, the cost to buy the actual elements to build you is closer to $150,000.
Okay, wait. $150,000 compared to $5? That's a serious upgrade.
It is, but it's funny, the bulk of you isn't actually rare or expensive stuff.
No.
No, I mean, oxygen is about 61% of you. Hydrogen is another 10%. Most of that's just water, H2O, right? Which is cheap. The real value or cost isn't in the bulk elements. It's in getting everything else right. The copper, the iron, those trace elements like tin. You need tin, but maybe only 6 cents worth. Getting that tiny amount and all the other tiny amounts exactly where they need to be in the right form, that's the expensive part.
Ah, okay. So it's not the raw materials per se, it's the incredible engineering, the complexity of putting it all together and making it work. And that's really our mission for this deep dive, isn't it?
Yeah.
To see how this expensive collection of chemicals becomes you, a thinking, feeling being. We want to find those aha moments about ourselves.
Yeah.
So let's start with just the sheer scale of what's happening inside you right now. Stuff you don't even notice.
The scale is, it's almost unbelievable. Think about this. Just since you started that sentence, your body has probably made like a million new red blood cells.
A million already.
Yep, just churning them out constantly.
And those cells, they really work hard, don't they? They zip around your whole body, what is it, like 150,000 times before they're retired?
Exactly. It's this massive nonstop delivery and recycling program happening every second.
Okay, so that's the tiny scale. What about the big picture, the blueprint, the DNA?
Ah, the DNA. Right. If you took the DNA from just one of your cells, just one, and stretched it out, it'd be about, 6.5 feet long?
Wow. In one microscopic cell.
Yeah. Now, take the DNA from all your cells, your entire body, and stretch that out end to end.
Okay.
It would reach 10 billion miles.
10 billion. That goes past Pluto, doesn't it?
Way past Pluto. So you are quite literally cosmic in your own internal structure.
Huh. You're cosmic being packed into this very fragile container, which I guess needs defending. That leads us to the body's internal security forces, right? The silent battles.
Exactly. And this is where that $150,000 price tag really starts to make sense. We all worry about cancer, right?
Of course.
Well, the sources say that every single day, probably between 1 and 5 of your own cells, they go rogue. They turn cancerous.
Every day.
Every day. And your immune system. It just finds them and takes them out. No fuss, no alarms, just deals with it.
So my body is potentially fighting off cancer over 1,000 times a year without me having a clue.
Pretty much, yeah. Over 1,000 times, year in, year out. It's an absolutely incredible defense system.
We should probably be nicer to our immune systems. Give them a little thank you now and then.
Maybe we should. And it's doing all that while also hosting basically an entire ecosystem.
You mean the microbiome, all the bacteria and stuff.
Exactly. The trillions of microbes living on you and inside you. Altogether, they weigh about 3 pounds.
3 pounds? Hang on, isn't that about the same weight as your brain?
It is, roughly the same. So you're carrying around this whole other collection of life, sometimes called another organ, almost.
Wow. Okay. An extra 3-pound organ made of microbes? Weird.
It is a bit weird when you think about it. And speaking of organs, let's talk about the biggest one, your main interface with everything, the skin.
Right, the cutaneous system. It covers, 20 square feet, weighs maybe 10, 15 pounds?
Something like that, yeah. And it's amazing because unlike, say, your heart or your kidneys, which can fail, the skin, as a barrier, it basically never fails. It just keeps doing its job.
And it's not the same everywhere, is it? It's super thin on your eyelids.
Like 1/1000th of an inch thick there.
But then really thick on the soles of your feet. Built tough.
Exactly. But what's really wild is what's packed inside the skin. All the sensors.
Oh, right. For touch and temperature.
Yeah, you've got Meissner's corpuscles for light touch, Cassinian corpuscles that pick up vibrations, Ruffini corpuscles for heat, like touching a hot stove.
It's so specific. You don't just feel touch, you feel all these different kinds of contact. Pressure, texture, heat. vibration.
Right. But here's a weird fact from the sources.
Yeah.
Despite all that sophistication,
Yeah.
you don't actually have any specific receptors for wetness.
Really? But I know when I'm wet. After a shower or stepping in a puddle.
You do, but your brain is figuring that out indirectly. It's combining signals, probably cold and pressure signals, and interpreting that combination as wetness. It has to construct that feeling.
Huh. So the feeling of wet is something my brain makes up based on other clues?
Essentially, yes.
Yeah.
Which is a perfect lead-in to our next segment, really, because that's what the brain does. It manufactures your reality.
Okay, segment 2. The brain as a reality manufacturer. That sounds interesting.
It's maybe the most mind-bending part. Your brain isn't just passively receiving information from the outside world, it's actively creating the world you experience.
Guess so.
Well, think about light. Photons hitting your eye. They don't have any inherent color. Color is something your brain creates based on the wavelength of those photons.
Okay.
Same with sound. Sound waves entering your ear. They're just pressure variations in the air. They don't have sound. The experience of hearing music or a voice that's entirely generated inside your head. Scent molecules don't have an odor until your brain interprets them.
So all the richness of life, the colors, the sounds, the smells, it's all an internal production. A simulation almost.
In a way, yes. A very convincing one, built from raw sensory data, like that example about soap lather.
Oh yeah, I like that one. No matter what color the soap bar is, the foam is always white.
Right, because the way the tiny bubbles in the foam scatter light, your brain interprets that scattered light as white, regardless of the soap's actual pigment. The geometry creates the color experience.
That's wild. And the brain doesn't just create space and perception, it messes with time too, doesn't it?
It does, subtly. Think about watching someone chop wood from a distance. You see the axe hit before you hear the sound, right? Because light travels faster than sound.
Yeah, sure.
But in close quarters, say, watching TV, the light from the screen and the sound from the speakers reach you at slightly different times too. Your brain has to sort of smooth that out. It holds onto the faster signal, usually light, for a fraction of a second to let the slower signal catch up.
So it synchronizes everything?
Exactly. It irons out the differences so that you perceive things as happening simultaneously, which means, well, it means you're always living just a tiny fraction of a second in the past. You're experiencing a slightly delayed, edited version of reality.
We're living on a delay. Constantly.
A very, very short one. But yes, buffering reality for smoothness.
Okay, that's it. Wow. But this amazing editor, this brain, it's also quite vulnerable, isn't it? The sources mention strokes.
Extremely vulnerable. For humans, stroke is the second biggest killer worldwide, which is actually a bit of a mystery.
A mystery? How so?
Because most other mammals, they rarely have strokes. We seem uniquely susceptible.
Do we know why? Is it our big brains or standing upright or...
The sources don't really give a definitive answer. It might be lifestyle, it might be something about our specific brain structure and blood supply, but it's not fully understood why we're so prone to them compared to, say, a chimpanzee or a dog.
Another vulnerability seems to be memory. We think of it as this reliable recording, but the sources suggest not so much.
Not at all, really. Memory is described as being much more, well, hazy and mutable. Think of it less like a video recording and more like a Wikipedia page.
A Wikipedia page, how do you mean?
Well, every time you access a memory, you're not just playing it back, you're kind of rewriting it slightly. You pull up the last version, and the very act of remembering alters it, integrates new context, maybe smooths out inconsistencies. Then you save that slightly altered version.
So my memories are constantly being edited without my permission.
Basically, yes.
Ooh.
Which explains a lot about why eyewitness testimony can be so unreliable.
Right. There was that study mentioned about people remembering 9/11.
Exactly. They interviewed people right after and then again a year later, and nearly half the people significantly changed key details of their story, like whether they first heard about it on TV versus the radio or who they were with. Their memory had subconsciously rewritten itself to be a better, maybe more dramatic story.
That's slightly terrifying. My whole past is a wiki page someone else is editing.
Well, you're editing it unconsciously. But yeah, it's not a fixed archive. And what's strange is how bad our short-term memory usually is. Most people can only reliably hold on to about, 6 or 7 random digits or words for a few seconds?
Yeah, try reading me a phone number, I'll forget it instantly.
Right. It seems like we're designed to forget the immediate clutter. But that baseline is not the limit. With training.
Yeah, the memory champions.
Yeah. The sources mention one person recalling over 4,000 random digits. 4,140, I think it was. after just 30 minutes of studying them.
Okay, so the hardware is capable, we just don't usually use it that way. We filter constantly.
Precisely. We filter, we edit, we construct.
Which brings us nicely to segment 3, the fragility, but also the ingenuity of some core systems, things we rely on every moment.
Like swallowing. Just swallowing food or drink.
It seems simple, but it's actually quite dangerous, isn't it? Because the pipe for air and the pipe for food are the same at the top.
Exactly the same tunnel. The only thing preventing food from going down into your lungs or air into your stomach unnecessarily is this tiny little flap, the epiglottis.
The trapdoor.
The trapdoor, exactly. And its timing has to be absolutely perfect. Close off the airway when you swallow, open it when you breathe.
And somehow you can sit there at dinner, you're eating, talking, maybe laughing, taking a breath, having a drink, all using the same basic plumbing, and you don't even think about it. The system just juggles it all.
It's amazing orchestration. Most of the time.
Most of the time.
Yeah.
Because choking is a real danger.
It is. Sadly, around 5,000 people in the U.S., maybe 200 in the U.K., die each year from choking on food. That trapdoor system fails with catastrophic results.
A reminder of the delicate balance.
Wow.
Okay, let's move from that internal timing to the scaffolding, our bones.
Right. Our structure, we think of them as just inert supports, but they're pretty remarkable.
We usually say they're 206, right?
Right. That's the typical number, yeah. But the sources point out it actually varies a bit. About 1 person in 8, for instance, has an extra pair of ribs. A 13th pair.
Huh. I didn't know that.
Yeah.
And they're strong, obviously.
Incredibly strong. Stronger, weight for weight, than reinforced concrete. Most bones can handle about a ton of compression force.
A ton. Wow. But they're also light, aren't they? The whole skeleton doesn't weigh that much.
Surprisingly light. Only about 20 pounds in total for an average adult. That combination of extreme strength and lightness is key to our mobility.
And mobility requires muscles working with those bones.
A lot of muscles. Just the act of standing up from sitting takes about 100 muscles coordinating.
100 muscles just to stand up.
Roughly, yeah. And keeping all that muscle mass ready to go. That takes energy. A lot of energy.
Oh, my.
Well, your muscles make up about 40% of your body weight if you're reasonably lean. And just maintaining that muscle mass, even when you're completely resting, just sitting still, that uses up about 40% of your total daily energy budget.
40%. Just for maintenance.
Yeah.
Before I even move a muscle. Literally.
Exactly. Your muscles are metabolically expensive. They demand a huge amount of energy just to exist.
That's staggering. It really changes how you think about, well, just sitting around. Okay, let's try and wrap this up. Let's connect these amazing internal facts back to us living in these bodies day to day. We started with the idea that you're chemically cheap, but found out, nope, you're more like $150,000 worth of refined elements.
Right. And that cost reflects incredible complexity. DNA stretching past Pluto, an immune system fighting off thousands of potential cancers yearly without you knowing.
And then the brain, not just seeing the world, but actively creating your reality, color, sound, even smoothing out time for you.
While relying on these brilliantly engineered yet sometimes fragile systems like the epiglottis or bones, stronger than concrete but incredibly light, all powered by muscles that cost a fortune in energy just to maintain.
So the big picture is this. Your body is this incredibly active, complex, energy-hungry machine. It's designed for activity, constantly rebuilding, constantly defending, constantly spending that energy, especially on muscle upkeep.
Which leads to a really crucial, maybe even alarming, final point from the sources about how we treat these machines, especially regarding inactivity.
Right. Exercise is good, obviously. We know that. But the sources highlight the danger of the opposite, of sitting too much.
They do. Being a committed couch potato, and they define that as sitting for 6 hours or more per day.
Which is a lot of people with desk jobs and commuting.
A lot of people. Doing that increases the risk of dying early by almost 20% for men. And for women, it's nearly double that. Almost 40% increased risk.
40%. Just from sitting. That's huge.
It is. But here's the really provocative kicker. The part to really mull over.
Okay.
It seems, based on the research mentioned, that exercising doesn't necessarily cancel out the harm of prolonged sitting.
Wait, what? So my morning run doesn't make up for sitting at a desk all day?
That's what the sources suggest. It says, quote, "It doesn't seem to matter how much you exercise the rest of the time. You can't undo sitting."
You can't undo sitting.
Think about that energy cost. 40% of your resting energy just maintaining muscle. If you sit completely still for hours on end, you're effectively telling that system, we don't need this expensive hardware. The body is fundamentally built for movement, for activity. Prolonged stillness seems to be something we are penalized for at a very basic level, regardless of bursts of exercise.
So intervention isn't just adding exercise, but actively breaking up those long periods of sitting down. Get up, move around, counteract the stillness. Because you can't outrun a chair.
That seems to be the stark message. Motion is life, and stillness is risk.